Well, thank you for tuning in to your next lesson in Math 8. Today we are going to continue with comparing fractions, only we're calling it equivalent fractions because you're going to come up with what is equivalent. Ooh, another big word, huh? Not really. So, last time you were comparing fractions and trying to decide if they were equal or greater than or less than, and I want to show you a little shortcut on how to do that because, as you know, we do like working smarter, not harder. Let me get my pen here and get an ink color that you can actually see on this board. I guess we'll go with white since everything else is white. Nah, let's go with yellow because nothing else is yellow. It'll just be my writing that is. So let's look at that first one in the top left corner. 7/8, is it equal, less than, greater than, or whatever? You see the question mark, to 5/6. And kind of looking at them, it's hard to tell. So I want to show you a little trick. And some of you may know this already. I'm sure lots of other smart teachers have shown you this. Take those two and multiply them. So 7 times 6 is 42. Write that over here. And then take these two and multiply them. 8 times 5 is 40. Therefore, when you compare these two numbers, it's easy to compare those, right? 42 is bigger than 40. That means 7/8 is bigger than 5/6. So we would put that sign in there, okay? 7/8 is bigger. The bigger side faces the 7/8, and 5/6 is smaller, so the little pointy side points to the 5/6. Let's do another one. 2/3 compared to 3/4. Any guesses? I think I know, but I'm not going to tell. So we're first going to multiply these two and put that answer over here. I'm going to put it up top this time. 8. And then we compare these two. You guys see where this is going, I'll bet. 9. Which one's the bigger one? Well, this one right there. We're going to point to the little guy because the little side of the inequality sign points to the smaller one. The big side points to the bigger one. So there we go. 2/3 is actually smaller than 3/4. All right, let's do another example. Again, multiplying. 3 times 10 is 30. 5 times 6 is also 30. Yay, these two are equal or equivalent. Okay, equivalent. All right, now I'd like you to give one a try. And there's another one for you to do. Okay, let's talk about equivalent fractions. We know how to come up with whether or not they are. But what if you're given one and somebody says, give me another fraction that's equivalent to this one. So I'm telling you right now that 1/2 and 3/6 are equivalent. And here's how we can come up with that. What if I just gave you 1/2 and I say, give me an equivalent one that has a denominator of 6? Well, here's what we would do. We would look at it and say, all right, well, what they want is 2 to become a 6. What can I multiply the 2 times to become a 6? I can multiply it times 3, which is what I did here, right? So whatever I do to the bottom, I got to do to the top, and that's where I get the 3/6. Okay, it's pretty simple. You got to multiply the top and bottom by the same number, and you can turn it into another fraction that is equivalent. Let me show you a picture that also illustrates this for those of you visual people. So 1/2 and 3/6. So here's a rectangle shaded in 1/2 of it. Here's the same size rectangle but cut up into the 6 parts and shaded in 3 of them. Notice the 2 shaded parts are the same. They're the same size. So that means they are equal or equivalent. Here's some other ones. I want you to pause and really look at these. I'll talk about them for a minute. Notice we've got this little triangle on both sides, same thing. Over here it's 1/3 because it's broken up into 3 parts. This one's broken up into 6 parts. Notice the shaded areas match. Okay. Same thing with our dots. We have 5 dots here. Now we don't have 10 dots. We have 5 dots broken up into 2 each. Okay, so for 2/5, 2 dots are completely filled in. For 4/10, 4 of the sections. There's 10 sections. Okay. Pause and think about it. Here we have a hexagon, right? Is that 6 sides? Yeah. 1, 2, 3. Yeah, 6 sides. So 8/12. Notice the hexagon is broken up into 12. And over here, the hexagon is broken up into 6. Look at those shaded areas. Same. Right? 3/8, 6/16. I don't think I need to talk about that one, do I? Pause and think about this. Okay, so visually, we can look at a problem like this and say, oh, this one's easy because look at this. 1/2. If you think about visually what 1/2 should look like, okay, about half, it is half of the figure, all right? This 5/8 figure right here, that doesn't look like half, does it? Because there's 8 things and too many of them are colored. I'm going to jump over here because you can see what the middle one is. This one is not half of them are colored, and this one is half of them are colored. Okay, 4/8 is the same thing as 1/2, half of it. Okay, and if you think about it too, what number times 2 will give you 8? That'll be 4, right? So if I do 2 times 4, oh, yellow on white doesn't work so good on this, does it? I may have to change my ink color. Times 4. And the top one times 4. And the whole thing gives us 4/8, the equivalent fraction that we have down below. Let's look at this one, and you get to tell me which one is equivalent. Okay, another one for you. Pick out the one that's equivalent. And another one. You can do it. You can do it. Okay, now, what if we don't have our little charts and we can't use that? And then, whoa, this one is what's missing in this? Well, you can do a couple of different things. You can decide, first of all, what number times 4 gives us 12, okay? And then multiply the top number by that. You can do it that way, and that is very acceptable. Okay, so what number times 4 gives us 12? Well, that's 3. And so if we multiply both of them by 3, we will get 3 times 3 is 9/12. Okay, that's one way to do it. Another way would be to go back to our other thing here. 3 times 12 is 36. 4 times some number, which we called x here, gives us our x, okay? How do I come up with that number? Well, I could take 34 or 36 here and divide it by 4. And if I do that, I get 9 again. So it's really your choice which one makes the most sense to you. And that is not a minus sign, that's a multiplication sign, okay? So it's really up to you which way you want to do it. I prefer multiplying this times 3, recognizing that, and then multiplying that times 3. That's the way I like doing it. But, hey, the important thing here is to get the right answer. Let's see this again. Okay, so now we're missing the denominator on this side. So let's take a look at what changed. We went from a 1 to a 5. How do we turn a 1 into a 5? Multiplication only. We don't add, okay? Well, multiply by 5. So do that to this one too. And we get 25. 5 over 25 is equivalent to 1 over 5. What if you wanted to do that other thing, the multiplication thing? You would get 25 over here, and you would get 1 times x, or 1x. Well, what times 1 gives us 25? Same answer. Okay, so the answer to this problem is 5 over 25. Now it's your turn. one more. We did it. I hope you practiced it. Now, I want you to talk about it for me. I've got 2 questions for you. I want you to put them both in, and I'm going to give you 2 different places to do it, okay? So describe in your own words what it means for 2 fractions to be equivalent. Let's see. Okay, now for number 2, are those equivalent, or are they greater than, less than, whatever? Explain how you know that. Okay, guys, that's it for today's lesson. Thanks so much for watching.